where you check the y values and they say, oh, over here the y value is 6, over here the y value is -2. And if they say, here's some y value in between -2 and 6, will there be a place where that y value happens? Yeah, as long as the function is continuous. Okay, then we've got our mean value theorem. Mean value theorem says two criteria here. F has to be continuous on the closed interval and differentiable on the open interval, meaning I can find a derivative. The mean value theorem, that's the one where there was like a little picture and it looked something like this. You have to have a graph that's continuous and differentiable. You pick your endpoints. You connect those two with some sort of a line. What kind of a line is that? The pink one? What kind of a line? Secant line. Touches the curve twice. If you have a function that is continuous and differentiable, what the mean value theorem says is there's always going to be a place where your tangent line has the same slope as your secant line. Slope of secant line, that's how you're gonna use f of b minus f of a over b minus a. Slope of tangent, that's what this f prime of c is. That's your mean value theorem. The key for mean value theorem has to be continuous on the closed interval, differentiable on the open interval. You get both. The mean value theorem is pretty much the only theorem that asks you about derivative values. If it's asking you a question about derivative, think MVT. Extreme value theorem, your function has to be continuous on the closed interval. With the EVT, like maybe the picture you've got over here, is that you've got some function. It doesn't even have to be differentiable. You can have a sharp point. For any interval that I pick, here's my interval. There has to be an absolute max, and there has to be an absolute min. Now, does there have to be a relative max? The extreme value theorem doesn't promise anything about relative max. It doesn't promise anything about relative min. Now, for this graph that I drew, is there an absolute max? For this graph over here, is there an absolute max? Where? Right there. Right here? Absolute max? This is not an absolute max. This is the absolute max. The extreme value theorem, that's when we started looking at like, oh, it happens inside or it happens at an endpoint. This is a relative max because it does the kind of change that I want it to from increasing to decreasing. This is your absolute max. Relative min? What do you think, Juan? Do you see a relative min somewhere?
Where did they see the little cut?
The cusp, right? A cusp point can be a relative min. To be a relative min, I just need the graph to change from decreasing to increasing. Is there an absolute min? Is there an absolute min? That's a trick question. There is always an absolute min. If the extreme value theorem says if you have a continuous function on a closed interval, there's always a highest point, there's always a lowest point. For this particular graph, the absolute lowest point is right here at the relative min. It's possible to have a relative min that's an absolute min at the same time. All right, those are the three that are probably the hardest ones. After that, we just get into some memorization now. Fundamental theorem of calculus. F of b equals f of a plus the integral from a to b of f prime of x dx. Final value equals initial value plus the total change. Average value of a function, that's when we would do an integral from a to b of f of x dx times 1 over b minus a, or same thing divided by b minus a. Just get it copied down. Make sure that you have access to this information. Second fundamental theorem of calculus. This is the guy that connects Derivatives and integrals. We know that if you're going to take the derivative of the integral of a function, if the lower limit's a constant, what happens? These guys basically cancel each other off. It's what you would hope would happen. Derivatives, integrals, kind of inverses of one another. Your extended second fundamental theorem of calculus, derivative of the integral of a function, again from a constant. I meant to indicate constant over here. I meant to have a pen that writes. Constant. Function up here, it's going to be f of g of x times g prime. Looks a lot like the chain rule, but it's not the chain rule. Jasmine, you okay?
I was trying to read
This last one? L'Hopital's rule. L'Hopital's rule. If you're trying to find a limit, everyone loves L'Hopital. L'Hopital makes your life better. If you're taking a limit and you get 0 over 0, or you get infinity over infinity, that's what you call those indeterminate forms. What L'Hopital's rule says is, if you need to find the limit and you're getting 0 over 0 or infinity over infinity, what do? You take the limit of the derivative of the numerator divided by the derivative of the denominator. Don't use quotient rule. We're not talking about quotient rule here. L'Hopital's rule just says derivative of the top, derivative of the bottom, find the new limit. Whatever you get, that's the answer. All the friends okay? So here's what I want to do. I want to give you guys 4 minutes to either finish copying down the notes or find somebody to just start bouncing questions off of them. Maybe it's like, hey, what are the criteria for the mean value theorem? What does it take to apply the extreme value theorem? What's the fundamental theorem of calculus? These are all good questions to ask each other. I remember our having a conversation, and obviously knowing me, if it's a mistake that I made, I will get it fixed. But just to be honest, it's really hard. Did I pick up the homework? I forget we were, sorry. Huh?
Next time we don't remind you.
No, not you. When I don't get yours, I have a different fallback.
What is it?
Okie dokie, hokey pokey. Alright, so here's the plan for the next 30 minutes. Now that you've had a chance to review, name theorems, and get them all in one place, strongly recommend that for those of you that are doing the flashcards, turn these suckers into flashcards. Add some graphs. Find somebody that you can study with. Show me that you've made the flashcards, and I will sign off on your survival guide blue sheet that you're like doing the extra things outside of class. What I want us to do, sort of big group, is deal with two multiple choice questions that have both come from the AP exam. What is going to be a challenge with both of these questions, it is always a challenge. One of these showed up on the BC trimester 1 exam, and you guys know those are 7 very smart individuals. All, you know, the 7 fools that are in BC.
Oh.
Yeah, one of these questions, all 7 of them got wrong. It is the only question on the entire T1 exam that they all got wrong. When I saw it, I was like, gosh, something must be wrong with the data. Maybe there's something wrong with my answer key. No, nothing wrong with the answer key. These are the kinds of questions that always need to make you stop and think a little bit more. So I want to spend about 8 minutes talking our way through both of these, addressing as much of this as possible, and then we're going to do a little split. I'll spend some time with the Thrilled with the 3 folks doing a free response. Then we'll do some time with Fighting for a 5 folks on the free response. So I want you guys to take a minute, read over the first one, mark it up. Do all the things you would do if this was actually the AP exam. Be ready to talk.
If I was to write the whole paper about why we should call your first anniversary, call your first anniversary,
Say that again?
if I write you a paper.
Let's just get you to do your homework.
You got tissue?
Oh, these are multiple choice.
Ah, for movies.
I think I'm out.
On a continuous function, on a closed interval.
Sorry.
All right, so reading this question, f is a continuous function on a closed interval. That already, some bells and whistles should be going off here. I've got a continuous function on a closed interval. What theorems could I use? What could I possibly use?
And the no.
The intermediate value theorem?
Yes.
Right, that's one. Abraham, what else? The mean value theorem? Everybody's okay with mean value theorem?
Extreme value.
Why not mean value theorem?
Because it doesn't say it's a difference.
We don't have differentiability, Abraham, so I wouldn't be thinking about the mean value theorem, but I do get the intermediate value theorem and one more. There's one more, Adriana. The extreme value theorem. The intermediate value theorem, that's the one that we use to find roots. The extreme value theorem, that's the one that says you always have a max, you always have a min. Okay. Which of the following has to be true? There's a number c in the open interval such that f of c is equal to 0. Does there have to be a place where f of c is equal to 0? How many guys would say yes, that's true? Give me a thumbs up. No, that doesn't have to be true. Thumbs down. Have no idea? Jab your thumb into your eye. It has to be true. It doesn't have to be true. I have no idea. Okay, seeing most of you guys saying does not have to be true. Because you don't know anything about the y values, it doesn't have to be true that f of c is equal to 0. Now, if one of them had a positive value and one had a negative value, would you have to have a root?
Yes.
Absolutely. But you don't know about the endpoint, so you can't use this. Number 2, there's a number c in the open interval such that f of a is less than f of c is less than f of b. Does there have to be a place where the y value is in between f of a and f of b?
No.
Let's put a question mark next to that. Okay, there's a number c in the closed interval such that f of c is greater than or equal to f of x for all x in AB. Does there have to be a value for c that the y value is greater than or equal to all the other y values?
They could be the same.
Right, this here is your definition of what it means to be an absolute max, that the y value at that point is greater than or equal to all the other ones. Does that have to be true?
No.
Does there have to be an absolute max?
Yes.
Yes, that's what the extreme value theorem says. So this has to be true. Let's keep going. There's a number c in the open interval where the derivative has to be equal to 0. I don't know what the graph looks like. I can't make any promises about the derivative. That's what mean value theorem would tell me. So this one doesn't have to be true. That one doesn't have to be true. There's a number c in the open interval such that f prime of c equals f of b minus f of a over b minus a. They're asking you to think about mean value theorem,
No.
which we don't get the mean value theorem because we don't have differentiability. So it's either b or it's c. The reason why it's not b is if I look at this inequality, it says f of a, the value at the left endpoint has to be less than the value at the right endpoint. And what if your graph looked like that? We say here's x equals a, here's x equals b. The y value here is greater than the y value here no matter what. And so it's never going to be true that f of a is greater than f of b for this particular function. So I wouldn't pick b, I'm only going to go with c. Okay, with that, see what you can do with the next one. F is continuous. Okay, I think we know what that means. Non-linear just means the graph
Is it straight?
is not going to be a line. Function's continuous. For sure continuous. Edgar, what do you know for sure? What theorems do we get to use here?
The
The EVT, the extreme value theorem, right? The one that says there's always a max, there's always a min. And Eunice, any other theorems that we can use for sure? Your function's continuous. There's one more theorem we can use for sure, for sure, for sure. The intermediate value theorem. Okay, no promises about your mean value theorem. So it's continuous and nonlinear from -3 to 7. F of -3 is equal to 5. When I walked around, I saw a lot of folks that plotted some points and say, okay, here's -3, 5. F of 7 equals -5, so here's this guy down here. If there's no value where f prime of c is equal to -1, which of the following must be true? They're saying f prime of c can't be equal to -1. So is it true that for some k between -3 and 7, the derivative is less than -1? Maybe. For some k between -3 and 7, the derivative is greater than -1. Maybe. For some k, the derivative is equal to 0. Maybe.
well,
Between -3 and 7, f prime of k exists.
No. Never, it can't be -1.
it's the same for all values.
It's saying that this exists for all the values.
No.
No, not that one.
What?
Wait, if there's a maximum or
And by the way, this is the one that none of them get right. This would be the one. For some k between -3 and 7, f prime of k doesn't exist. Yeah, so we've got 5 just absolute questions here that we're not really sure. D for DeRozier, go with that.
F prime is the slope, so slope can be positive.
Jose, the key is what you just said. F prime means slope. What's so special about -1? -1 is the slope that you get if you connect these two. Right, slope of secant is going to be 5 minus -5, change in y, over -3 minus 7. That's 10 over -10, -1. What they've told you in the beginning is that you will never find a place where the slope is -1. But if -1 is the slope of the secant line that connects these two, isn't there always going to be a place where the slope is equal to -1? Yep. If the slope of the secant line is -1, isn't it always true that there's a place where the slope of the tangent line is equal to -1?
Oh yeah, the theorem.
Don't we have a theorem that says that?
Yeah. It's one of them.
Slope of secant is -1. They're saying for some reason the slope of the tangent line can't be -1. There's a reason. What's necessary in order to use the mean value theorem? Go back to your notes. What do you need to have?
Differentiability.
You have to have differentiability. That means that the derivative would have to exist everywhere. If the derivative exists everywhere, stay with me on this line of thinking here. If the derivative were to exist everywhere between -3 and 7, then we would say that the function is differentiable. Okay? But if the function is continuous and differentiable, then what happens? If your function's continuous and the function's differentiable, you get to use the mean value theorem. And the mean value theorem would say, hey, if I find the slope of the secant line, there has to be a place where the tangent line has the same slope. But that can't happen. Which must mean that you can't use the mean value theorem. And the reason you can't use the mean value theorem, the function's not differentiable. And why is the function not differentiable? Because there has to be some place where the derivative doesn't exist. There has to be at least one time. And that's why it's going to be E. And that's the one that nobody in Calc BC got this one right. Despite their trying really, 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 really hard. Nobody got that one right. Okay? That's still a really tricky one. We've got about 20 minutes left. I want to totally split the group. So if you are in the thrilled with a 3, you're over here. We're going to work on one free response question. Fancy 5s, fighting for a 5, whatever the F word is for the 5s. You guys are over here. We're going to keep filming. The fantastic 5s, yes. The thunderous 3s. Okay, put 10 minutes on the clock. Everybody's working on the same one. All right. All right, so everybody that's in the house, we're going to look at this first model free response question. This is not the homework tonight. This is the one that we're going to work on for the next 10 minutes. And then fighting for a 5, we're going to switch. Okay. So, Take a minute, mark it up, read through this, make sure you understand what's going on. During rush hour, there's a backup of cars and a bridge is tolled. The number of vehicles in line at time t is modeled by a twice differentiable function L. Values of L are in the table below. One of the keywords here,
Twice different.
twice differentiable, which means what?
Double prime.
Okay. It means three things. It means continuous, right? You get continuity. The other thing that you get differentiable, right? So like L prime exists
Velocity and acceleration.
and L double prime exists. Not velocity and acceleration, Jose, because we're not talking about like position and velocity. We're talking about number of cars. So T is the minutes, L of T is the number of vehicles. Easy question, here it comes. For 0 less than or equal to T less than or equal to 60, what is the minimum number of times that the number of cars at the toll booth will be, what is it, 85? Minimum number of times the number of cars is going to be 85. When you think you got it, show me on your fingers. I see 3, I see 1, I see 2,
No, I think
2,
no, 3.
3,
4. No, 4.
4. It's like we're at an auction.
No,
Anthony's at 4 as well.
7.
For those of you that are saying 4, you want to read this question one more time.
Oh, 80.
85.
10 and 30.
Jasmine, give me an interval where the number of cars has to be equal to 85. From 10 to 30, the number of cars has to be 85. What drew your attention over here? Because 85 is between 60 and 100, so that's place. That's place. Jennifer, give me another one.
30 to 45.
30 to 45 has to be a number of cars between 85 because one value is 100, one value is 80. Good. Daisy, give me another one.
From 45 to 60.
From 45 to 60 because?
Because it's from 80 to 90.
80 to 90. But why aren't there 4 intervals, David?
Because they want the least amount.
Because what?
They want the least amount.
That's not why. Anthony, why?
The interval.
The actual interval that they care about, they set you up. You have to answer their question, not the one you wish they were asking you. Between 0 and 60. So the answer to their first question is 3 times. Make sure you answer their question. I would guarantee there's going to be a point for that. Now, here's the why. What you just used, if you were scanning the y values, you use the intermediate value theorem. Jennifer, can you use the intermediate value theorem here? Yes, why? What do you know about this function that says, yeah, the intermediate value theorem's okay? There you go. So you'd want to say something like, since L of t is continuous, the IVT applies. All the friends okay? Okay. Yeah.
For that one, you don't have to put like the integrals and then put like a little like therefore.
That's exactly where we're going. But I first have to convince the reader I know I can use the intermediate value theorem because I have continuity.
What if we draw a graph?
Don't draw a graph. If the graph is helpful for you, great, draw it, but it cannot be your argument. You gotta get me continuity to get to the IVT. Now, Jose, what was the first interval that we said? 10 and 30. So I'd say something like L of 10 equals, what is that, 60? And L of 30 is equal to 100. And then I'd make a statement without lying. 85 is between 60 and 100. Therefore, the 3 dots Juan was waiting for, L of t equals 85 at least once on the interval 10, 30. But you've got to look at the endpoints. You've got to convince me that the y value that I'm asking you about is in between the endpoints, and that's why it's going to be equal to it once. We're good? All right, and then if you guys are okay, I'm just going to be like, same, please God, don't write this on the AP exam. Same for, what are the other intervals?
30, 45, 45.
30 to 45. And the other one, what is it, 45 to 60?
Write a note,
Do
not
we
to write
get
this
points or
someplace.
we're not?
Don't write that.
Is it risky?
It applies.
It's not risky, it's stupid.
Oh, so you, okay.
It's not even risky, it is just guaranteed to be like, I have too many points, come take them.
Okay, can we just say like it also applies to the involves of? It's
The function.
the function.
It's a good thing I never actually watch these videos. If I think about all the faces that I make, and I'm like, oh God.
Oh, you don't want
This
it?
is not attractive.
I know the stuff, why would I watch it? All right, A, B. For the for 0 less than or equal to t less than or equal to 60, what's the fewest number of times at which L prime of t is equal to 0? Ooh-wee. Ooh-wee.
What is decrease?
Does L prime of t have to be equal to 0? Fighting for a 5. I'm coming over to you guys.
1. Only 1. Because only 1 is a decrease. So the prime will be negative.
Oh wait, just turn
And
this.
then you can do the
How does this graph look?
intermediate theorem. Say 0 is 2. It has to cross that 0, 0, so it's y.
The derivative.
The
You
derivative.
gotta be careful with the derivative here.
The derivative is positive.
What does that do?
So when it goes
It's
to
like that.
it has to go to negative.
So if it's increasing, that means it's positive. It goes from positive to negative, but then it decreases at 45. So that means it has to be equal 0 at that point. From somewhere from there, from 30 to 45, it must be.
The decrease is to go to negative.
That's exactly what it is. What do you mean?
So yeah.
All right. I'm gonna actually spin off and just work with the 5 folks for a little bit. The most successful arguments seem to be the folks that actually considered, like, what does the graph look like? Right? If you plotted the points, if you said, okay, here's my graph, and I've got the point 0, 10, and here's 10, 60, and here's 30, 100, and now here's 45, 80, and then here's 60, 90. How many times do I have to have a derivative equal to 0? If I'm going to go through this point, this point, this point, this point, this point, and do it in a way where I'm continuous and differentiable, then that means that my graph is doing something not necessarily exactly like this. This is where the graph can lie to you. Okay? But the idea is somewhere over here, L prime of t is equal to 0, and somewhere over here, L prime of t is equal to 0. So the right answer to this question is 2 times. Okay? And for the sake of what I wanted to accomplish with you guys right now, I'm going to say that is good enough. And if we could switch. Fighting for a 5 over here, or farting your way to a 5, if that's the F word for you. Okay? For the thrilled with a 3, what I want you guys to do tonight for homework is work on the multiple choice. Farting your way to a 5 or over here. Alright, we got all the smart, good looking people. Okay. Friends over here, we're okay? How did that last problem go? Did we get the right answers?
Yeah.
Did we need to work on the write-up a little bit?
Permanent mark.
Okay, I can deal with, got the right answer, gotta work on the write-up a little bit. With this one, we've only got about 6 minutes. Let's see how far we can go with this. So for the second one, read it over, mark it up, you're ready to talk. All the friends here are working with multiple. Alright. He's been parked right on a straight track during the time interval 0 to 45 seconds. The vehicle's velocity measured in meters per second and acceleration are shown in the table below. Both V and A are differentiable. And for you guys, everybody's okay with that, right? Just keep in mind, as soon as you know that they're differentiable, I'm really saying continuous and derivative exists. So what theorem do we get? If the functions are continuous and differentiable, which theorems do you get? All of them! All the theorems in the world. Well, maybe that's a little bit of an exaggeration. You get the IVT, you get the EVT, you get the MVT. Right, this is the one that you're going to use to like look at the Y values. The EVT, this is the one that says always going to be a max, always going to be a min. The MVT, the derivative has particular values. Alright, part A. What's the minimum number of times at which the vehicle is stopped? What are you really looking for here, Jonathan? How would you make a decision? Right, if the vehicle is stopped, the velocity is equal to 0, I can do a scan of this list. Kimberly, any places where you know for sure the velocity is going to be equal to 0? Okay, not at t equals 0 and t equals 10, but in between t equals 0 and t equals 10. So if I'm just counting, I got 1. Marvin, anywhere else? At 40. At 40, for sure. Twice. Anywhere else? I think that's it, right? We're going from positive to negative, happens once. Negative to negative. Could the vehicle have stopped in between here? Could the velocity be equal to 0? The answer is yes, it could have been 0. Right, you're dealing with a 10-second gap. The vehicle could have stopped. But does it have to have stopped? No. It must have stopped to go from positive to negative. But not over here, not over here, not over here. Does it have to stop on 30 to 40? Yes, for sure we know it stopped at 40. That's the second time. But I don't get to use it again. So for part A, we're just going to say 2 times. And if you guys are good, we're going to skip the write-up for right now. All right, B. Minimum number of times that the speed of the vehicle is equal to 1. I need the speed to be equal to 1. Have a conversation with somebody near you. What are you going to do? All right, Christian, are there any places where you know for sure the speed has to be equal to 1?
From 30 to 40 and then from 40 to 40.
Okay, I hear Christian saying that between 30 and 40 and between 40 and 45, the speed has to be equal to 1. Tell me more about that decision.
Speed is the derivative absolute value of velocity.
Speed is the absolute value of velocity. If the absolute value of velocity is equal to 1, what do we know?
That's all the
You have 4 highlighters.
Right, the velocity equals 1 or the velocity equals -1. I've got to consider both cases here. If I do a quick scan, when is velocity going to be equal to 1? One time here. And where else?
From 40 to 45.
From 40 to 45. So we could say like on the interval 0 to 10 and on the interval 40 to 45, when's the velocity equal to -1? Right, actually on this interval again.
Oh, sorry.
So I'd say on the interval 0 to 10 and anywhere else.
30 to 40.
Would it be, right? And 30 to 40. The importance of this interval being listed twice is that 2 things happen. The velocity is equal to 1 and the velocity is equal to -1. Okay, for the Thrilled for a 3 folks, multiple choice, that's what you're doing tonight for homework, unless of course you're doing the 2 a day after school, in which case stop doing the homework. Friends over here real quick, acceleration has to be equal to 0. Somewhere, where do you see it, Nora? From where? I think I agree with what you're saying, I just can't hear it. If I scan the data quickly, you're going to say, no, the acceleration doesn't have to be equal to 0. Marvin, what do you see? 40 to 45? No, that's not the place. Let me write acceleration in a different way. Acceleration is the derivative of the velocity. Is there a place where the derivative of velocity has to be 0?
And I was going to say 40 because the velocity is at 0.
The velocity is 0, but we're looking for the change in velocity. I need to let you guys go. The key is if I look, I saw it just a bit ago,
Do they from 10 to 25?
between 10 and 25. The velocity at 10 is -6.2, the velocity at 25 is -6.2. If I imagine the graph of velocity and I connect those 2 with a secant line, there has to be a place where the derivative is equal to 0. Okay, see you guys later. Hello, friend. The homework is to do the multiple choice. If you're not able to stay, if you're doing the 2 a day, then that's the homework and we're done. Fine, that's all the homework there. I was like, I
Yo le dije
cannot
que yo no
press
pierdo.
on you enough that the reason that we're having this conversation, no one doubts that you're right. No doubt about it. It's the in-class part, it is the out-of-class part that is